Okay, so we're back, still looking at section 1.5. We want to look at solving exponential problems. And so these are like, if you look in the book, problems 29 through 38 in the book, section 2.5. And the only real thing to remember about in solving these problems is y equals e to the x does not have 0 in its range. Right, so when you look at the graph starts very close to 0 but isn't actually at 0, and then it goes up, right? And that's my x, that's my y. There's no y equal e to the x. So, to write it another way, e to the x does not equal 0 ever. E to the x is always strictly positive. So, suppose you're given this problem, and we'll call it problem 1. That's a good name for a problem. Solve 12 to the 2 minus 3x equals 12 to the x squared plus 7. Oops, and I don't want 2 there, I actually want 14. So 12 to the 14 minus 3x equals 12 to the x squared plus 7. And that is what I want. And note, let me just go back and say, right, it isn't just e to the x, right? Any base to the x, it's never equal to 0. It doesn't matter what the base is. So, solve 14 minus 3x equals 12 to the x squared plus 7. We note that we have the same base. So, if this base raised to something is equal to the same base raised to the same thing, then that tells me if they're equal, the exponents are equal. So this problem here, that turns into 14 minus 3x equals x squared plus 7. So how do you solve that? Well, it's a quadratic equation, right? Because there's an x squared in it. How do you solve quadratic equations? Get everything onto one side. So we'll move the 14 minus 3x over to the right side. So 0 equals x squared. The minus 3x comes over as a plus 3x. The 14 comes over as a minus 7. The 14 comes over as a minus 14. 7 minus 14 is minus 7. So that's a quadratic equation that we're trying to solve. This doesn't factor because the 7 factors into 7 times 1, right? And you can't get a 3 out of that. So there's two ways to deal with this. Either quadratic formula, which is pretty much the faster way to do this, because x equals, oops, let's move this over a little bit so I can get my equal sign. X equals negative b plus or minus the square root of b squared, so that's 9, minus 4ac. And you have to be a little bit careful here because there's a minus on the 7, so we'll actually write that down. 4 times 1 times minus 7, all over 2a, and a is 1, so it's just over 2. So now we can write this out a little bit. Minus 3 plus or minus square root of 9 minus 4 times minus 7 is a plus 28, all over 2. X equals minus 3 plus or minus square root of 37, all over 2. Really nothing you can do with the square root of 37 because 37 is actually a prime number. If you wanted to, you could break it into two fractions like this, just depending on your mania for neatness. So that's one way to do it. The quadratic formula is pretty quick. X squared plus 3x minus 7 equals 0. Another way to do that is, or complete the square, because we learned how to do that previously. And so you can solve quadratic equations by that. Right? And we have x squared plus 3x minus 7 equals 0. We look at 3. You take half of that and square it, and that gives you 9 over 4. And then we take that, add the 9 over 4, subtract the 9 over 4, and you still have the minus 7 equals 0. Haven't changed anything because this is 0, but these three terms now are a perfect square. And what is the perfect square that we're dealing with? It's x plus something, quantity squared. What's the something? That's always this thing. It's 1/2 of the coefficient of x. So it's x plus 3 halves quantity squared minus 9/4. Common denominator will make that a minus 28 over 7. Not 28 over 7, 28 over 4. That's what minus 7 is. Great, so what do we have? X plus 3 halves, quantity squared, minus, well, 9 plus 28 is 37 over 4 equals 0. And this is easy to solve. Whenever anything has been completed the square form, you can just take the minus 37 over 4, move it over to the other side, take the square root of both sides. Square root of 37 is, well, we don't know what it is. It's square root of 37, but square root of 4 is 2. And x equals minus 3 halves plus or minus square root of 37 over 2. And note, if we go all the way back up, that's exactly what the quadratic formula gave us, which isn't actually a surprise because the quadratic formula is completing the square, and so we sort of expect that to happen. Okay, so going back to exponentials though, right? Same base, then the exponents must be equal. So you take these two, set them equal to each other, you get a quadratic equation, solve it. Second problem number 2 is, suppose we have 4x squared times e to the x plus 2 times x times e to the x minus e to the x, and that's x there, equals 0. And we want to solve this for x, find out what x is. Well, the e to the x is a common term, so we factor that out. What do we have? We have e to the x times 4x squared plus 2x minus 1 equals 0. Okay, so if two things multiplied together equals 0, then either this one is 0 or this one is 0. So either e to the x equals 0 or 4x squared plus 2x minus 1, minus 1 equals 0. But what do we know about e to the x? If we go way back up, e to the x does not equal 0. Ever. Always. So, e to the x is not equal to 0. So, are there any solutions to this? E to the x equals 0. No solutions. Okay. So, if this equation here has any solutions at all, if there's any x's you can plug in, they have to come from this quadratic part. And that's, again, I'll just go with the quadratic formula, negative b, which is a minus 2, plus or minus b squared, 2 squared is 4, minus 4, okay, so it's a little bit complicated, so a is 4, c is minus 1, so that's my 4ac, all over 2a, a is 4 here, so it's all over 8. So x equals minus 2 plus or minus the square root of 4. 4 times 4 is 16. Minus 1 times another minus makes it a plus. So plus 16 all over 8. X equals minus 2 plus or minus square root of 20 over 8. That can be simplified, right? If this was a quiz or a test or something, you could stop here, but I'm a math professor, and for some odd reason I enjoy simplifying things. So, minus 2 plus or minus, what's the square root of 4 times 5? Well, the square root of 4 is 2, square root of 5 is, well, we can't simplify that. All over 8, so you get that. And this can be simplified because you can factor 2 out, minus 1 plus or minus square root of 5, all over 8, and then you can do a little bit of cancellation. And so you get x is minus 1 plus or minus root 5, all over 4, which is the same thing as minus 1/4 plus or minus root 5 over 4, if you like your answers as separate fractions. And so that's about it on solving exponential equations. Again, two key points here. E to the x equals 0. No solutions to that ever. And if an equation has the same base on either side,